Question says, what is the purpose of multiplexing? FDM is for analog signals, TDM is for digital signals. Explain why. First, let's look at the scenario when multiplexing is not used. If we see this figure, we can see for separate source 1 and source 2, we have a separate channels for different receivers. So we can see there is a separate channel between source 1 and receiver 1, source 1 and receiver 2. And suppose the distance between them is 1000 kilometer. So in this case, we can see for every source and receiver, we have a separate channel. That means more channels are used here. Channels are used. And also, if we see, suppose at a time, suppose sender 1 is not sending any information or signal, R1. In that case, this channel will be free and it cannot be used by any other source and receiver because it is not connected between them. So in that case, this channel will be free. That means we can say the bandwidth utilization is not efficient. Utilization is not efficient. And also we can say since there are since I have made only two source and three receiver, there can be thousands of sources and thousands of receiver. In that case, the network will be huge. Hence, more cost will be incurred. Right. Now let's see a scenario where multiplexing is done. So what happens in multiplexing? There are multiple senders, right? And all the senders sends a signal to multiplexer. And what multiplexer does, it combines the signals. We can see it takes all the signals from all the senders and it combines and into a one signals. We can see only one signal is coming out of multiplexer and it is going through a demultiplexer. And after passing through demultiplexer, it again bring back the signals into its original form. It bring back the signal into its original form. In this way, we can see this is 1000 kilometer. We can see only one channel is required of 1000 kilometer. Even though some of the senders are not sending any of the information and some are sending. In this scenario also, we can see the bandwidth utilization is more compared to network where multiplexing is not used. Now let's look at the definition. Multiplexing is the process of sharing a medium or bandwidth. We can see in the case of multiplexing, we are sharing a single medium with multiple senders. Second part, it combines several signals from many sources and transmits them across a single communication of physical line. That's what we have discussed. Now, what are the purpose? So all the disadvantage of not using multiplexing can be a purpose of using a multiplexing. If we see, there is a chance of collision when multiple signals shares the same medium. That means we have seen that if we use separate medium, then it is not efficient. But when we use a common channel between multiple sources and receiver, if we use common channel, so we can't directly send all the signals in this channel. There must be some technique by which we use this common channel. That technique is called multiplexing. And some techniques are called TDM, WDM, and FDM. That's what it is saying. We can't directly send all the signals in one channels. Then in that case, there is a chance of collision. Multiplexing minimizes the number of physical connections or wireless channels required. So if we see in this, there are multiple channels, but in this one, there is only one channel between them. So it reduces the channels, and it is costly to send multiple diverse signals separately and requires more wires, which increases the network overall cost. That means if we have separate channel, that means more cables is required. More cables means more cost will be required. So to overcome this, we use multiplexing. And bandwidth is effectively utilized. If we have a common channel which shares across multiple senders, then in that case, efficiency or bandwidth utilization will be more. Now let's look at this multiplexing technique. We see the multiplexing technique is categorized into two parts, analog and digital. Digital means zero ones kind of thing, and analog means, when we talk about analog, we talk about frequency and wavelength. It is like a sine curve, for example. So technique used in analogs are FDM, that is frequency division multiplexing, and WDM, that is wavelength division multiplexing. And in case of digital, we use TDM, that is time division multiplexing. And it is further categorized as synchronous and asynchronous. Now let's see what happens. If we see, if we see a setup box at our home, setup box at our home, we know that a single cable is connected to our setup box, right? And from that setup box, our television is connected. So in this cable, there are multiple signals, like there are multiple channels we see in our television, and all the signals comes through same wire. How it comes, how it doesn't collide, how it doesn't mix up, because every channel signals have different frequencies and wavelength. So we can say, suppose colors have different frequency and wavelength. Z channels have different frequency and wavelength. Like this star has different frequency and wavelength. So when we use multiplexing technique in this, so for example, there is one curve, another curve, another curve. When we combine all this using multiplexer, it generates only one signal, and it generates some common curve. And when it is passed through demultiplexer, again it brings back the signals, all the signals into its original form. And this is displayed in our television. And in case of digital signals, digital signals means zero ones kind of thing. If we mix up all the signals, suppose there is source 1, source 2, source 3, and it is like 0101, it is 1010, it is 100 kind of thing. If we mix up these signals, again we will get some kind of 10001, some pattern. But at the receiver end, it will not be able to separate the signals, since there is no such things to separate out. Since all the signals are digital, like zero ones, there is no way to separate the signals out. So when we have digital signals, we don't mix up the signals. We don't mix up. Instead, we give separate chances. Suppose there is a common channel between senders and receivers. And suppose this is a time graph. So we can say at a particular time, this channel, this channel will be used by only S1. And in the next time slot, this channel will be used by S2. In the next time slot, this channel will be used by S3. Now again, turn of S1 will come. Again S2. Like this it happens. So this is called time division multiplexing. So in this case, when we have digital signals, since we cannot bring back the signals into its original form after combining, so we don't combine in the signals in this. Instead, we give separate time slot for each of the separate time slots for each of the receiver. But in analog, we have seen we combine the signals and based on the frequencies or wavelength, we are able to bring back the signals into its original form. Now let's see what question was saying. FDM is for analog signals and TDM is for digital signals. So FDM is typically used when analog signals because analog signals can vary continuously over a range of frequencies. That's what we have said, like for colors, Z channel, star channel have different frequencies. In FDM, the available frequency spectrum is divided into non-overlapping frequency band, with each bands allocated to a different signals. So since every signal have different frequencies, it doesn't overlap. Though we combine and generate a single signal, after it passes through a demultiplexer, it is able to bring back the signals into its original form. And this allows multiple analog signals to transmit simultaneously over the same medium without interfering with each other. TDM is commonly used with digital signals because digital signals are represented by discrete values, that is zeros, ones, that can be sampled at regular intervals. That means time slots. In TDM, different data streams are assigned specific time slot within a fixed time frame. Each signal occupies all its allocated time slot and signals are transmitted sequentially.